Hi friends, my name is E, and today we're continuing to hack on the Gleam programming language. This will be the third video in a series of adding the TypeScript definition output to the JavaScript target for Gleam. And today we're finally finishing everything up, hopefully. If you haven't watched the previous two videos, highly recommend it. Also recommend, again, checking out the Gleam programming language itself. And today, this is the final ticket. Just to reiterate, we are trying to add TypeScript type definitions for Gleam modules. So currently, Gleam can output JavaScript, but that JavaScript is untyped, and we're going to basically continue to finish adding TypeScript definition sidecar type definition files. So let's just jump right into the code, shall we? So where we left things, if I were to pull up our test here, is we are successfully generating the files. We're successfully adding a import for the prelude, but what we're not yet doing is adding imports for other external modules. So if you take a look, in this test, we're importing from this other module these constructors, and we're outputting that constructor, and we are correctly saying the type that this is outputting. This is going to output a one type. But what you're noticing is we're missing both a sort of prefix to this type, as well as the actual import of this type here. But we, in the last video, were successfully able to get the preludes to at least generate. And full disclosure, this is actually my second take at adding this. The first time I tried doing this, I did it completely all wrong. So hopefully this time we're going to do it right. So we're going to pull up our JavaScript Rust module, as well as our TypeScript Rust module. And if we jump down to the actual compile function, you'll see that right now we are going through each statement and mapping them into the TypeScript equivalent. And then we intersperse them with some new lines. And then finally, we check, did we use the prelude? And if so, we just manually add that import here. And then finally, we output the rest of our statements. And if we didn't use the prelude, we just output the statements by itself. Let's take a look at what JavaScript is doing here. So if we jump down to the compile function here, you'll notice it looks very similar. We're also mapping through all the statements, then interspersing them with some new lines. Here, it's manually adding each prelude usage to its own import, but we decided not to do that. We just said we would just import star. And then finally, it is mixing those imports and export statements nicely down here. So the key difference, if we look, is up here, it has this line, which is collecting all of the imports into some sort of object that we can then print out later. And that's kind of what we're missing in our TypeScript module. So let's go jump to TypeScript, and let's just kind of copy paste actually a lot of this usage. So we'll go to the top of our compile function. We'll add collecting of all the imports. We now need to copy paste that collect import. So let's find that in here. There it is. So let's just copy this for now. And then we'll paste it down here. Now we're at least going through each of these statements and deciding when should we import something. So right now, in JavaScript, there's sometimes you need to import an external function if it's coming from a non-empty module. But for the TypeScript definitions, we actually don't care about that. So what we're going to do here is just treat these the same way that we treat all the rest. And that's as easy as doing that and deleting this line, because the only thing that we're going to care about is the actual import statements. And then the other thing that we're going to do is we don't care about the alias that it's coming in as or any unqualified imports, the individual imports. So we're just going to toss these two arguments. So the only thing that we care about is what package is this import coming from, because that will generate the path, as well as what's the name of the module of this import, because that will determine what variable we assign this to. And so now we should be getting, we don't have register import inside there. So let's just go steal that code as well. and we'll modify it to make sure it works for TypeScript. And so here, like I said, we'll remove these two options because we don't need those. And then the module name, instead of coming from that alias, we're just going to grab this part and say let module name is equal to just the last part of that. And we'll say the TypeScript generator, going to identify the import module name. And then we will prefix it with a $sign here. We will correctly generate a path, but you'll notice that this import path is also missing. So that's right here. So let's just copy paste that as well. And what's nice about this one is the only thing that we really have to change here is change these extensions from MJS to .d.ts, because the only things that we're going to be importing are these TypeScript definition files. There we go. So that should be all that we need to do to change that. We'll even keep this to do. All right. Next thing it's going to be complaining about is we have not actually imported this imports object that JavaScript's using. So we're just going to quickly do that. And now we can get rid of all this unqualified stuff because we don't need that. And we can just replace these unqualified imports with an empty array. And let's see. Nope, missing a semicolon. That should be all we need to do to register our imports. I see, unused. Any other things that we need to do? Oh, and now it's saying, hey, now that you have all these imports, you're not doing anything with them. So what should you do here? Let us just find out what JavaScript's doing. So when it finds its imports, we basically get to skip all of this for the most part. We do need some sort of equivalent when the prelude is used. So instead of doing this, what I think we're going to do is when we use the prelude, we're just going to add to the imports. So we're just going to say imports dot register module. And then that needs a path. And then that needs the name of the module. So let's just call this gleam.toString. Because this is exactly what, if we look at what register prelude is using, this is exactly what it's doing here. So it's naming the module Gleam. So that's what we want to do as well. And we'll just copy paste how this path is generated. So now let's see. Hopefully, oh, and this takes a third, which is the members, but we don't care about the members. We just care about importing the module itself. And now it should be complaining that, hey, you're not actually at the end of this function returning what I thought you would be. And so we're just going to go and copy paste the formatting that JavaScript is already doing. So this says, if we have no imports and we have no statements, then just export nothing, which also makes sense for TypeScript. And then if we don't have any imports, but we do have statements, then just push into the statements a line. And I believe it's yelling at us because we have not made statements mutatable. So we'll just go quickly do that. So we'll push a new line at the very end and just output the statements. Otherwise, if we only have imports, then we're just going to put that. And then finally, if we have both imports and statements, we'll first do the imports, then a new line, then the statements, then a new line, which kind of makes sense for us too. See, cool. No more errors. And if we run our tests, let's see what happens now. All right. Well, this is already starting to look different. So let's see. We are both, I see. We are importing Gleam in this test, which comes out as one of these two lines, and we're using the prelude, which causes a different line of code to be hit. So one of these is being prefixed with the $sign, one of these is not. And I believe that's probably on me for not prefixing this with the $sign here. So if we do that, hopefully we won't have duplicates anymore. And we'll wait for some compilation so we can see our tests. But I think that should have removed the duplicates. There we go. So now instead of our kind of manual importing of the prelude here, you're now seeing that we are importing Gleam from gleam.d.ts. And off camera, what I've done is I've made it so that this file is outputted. Currently, there's a gleam.m.js that's outputted, but not a gleam.d.ts that's outputted at the root of the build folder. But I've gone ahead and made sure that this happens as well. So this is the correct import. And to keep things the same, instead of calling this prelude, I'll call it $Gleam, because this is exactly what JavaScript's doing, is it's calling this thing $Gleam. So this now looks correct. Well, actually, I take it back. It does not look correct because we're still referring to the old prelude name here. So we actually have to go to our type printer. So if we close this down and we go to our type printer, we should be able to, in all these places, just change these to prelude dot. So prelude dot with $Gleam dot. And yes. There we go. Now that looks correct. So let us now do a review and start checking in the things that we want. Oh, actually, let's cancel this because we need to actually run the test first to actually generate the new versions of all these. And then we should be able to start checking in because these now should be in a pretty good state. All right. Now let's do it. So close. So close. So what's happening here? We now have our import statement. Yay. This is all, that looks correct. We are importing this other module, just like we're doing it here in Gleam. We are prefixing it with the $, but you'll notice, even though this is returning a 1 type, because 2 is the constructor, but 1 is the name of the actual type, we are not prefixing this. So this should be $other.1. So we still have a little bit of work to do. So we have to go to our type printer. So let's just skip all these for now. And then, oops. Sorry, my Vim freaking out there for a second. So let's go to our type printer. And when we have an app type, which is types that are coming from another module, we need to grab that module name and we need to pass it down to our print type app. And if we go down here, so now the name should be not just this, not just the name of the actual type, but we need to prefix it. So we're going to open up our docvec. And the first thing we're going to do here is, well, actually, we need to grab that module as a third argument. So we're going to say module here is a pointer to an array of strings. And so we're going to say let module name equal to module dot last dot expect. And we'll just keep the empty for now, and I'll just copy paste the old message in just a sec. There we go. Actually, we'll just copy literally all of this. Oops, going back to the wrong place. Ooh, okay. Sorry, need to find where we were just working. I've lost my place. There we go. And we're in the type printer. Okay, there we go. So now we have our module name, and so we can actually just do that, followed by a dot, followed by the old name, and then we should be good. What is it yelling at us about? Let's just try running the test. See if we can get, whoops. That was not what I wanted to do. That's what I wanted to do. Okay. So it is saying no rules expected this token in macro call. So we probably have the wrong number of parentheses. No, that looks correct. Oh, it's not supposed to be, that is supposed to be a comma. There we go. Now we should be able to run our tests. And hopefully we are going to start seeing some good outputs, because now we should have prefixed the actual module name using the same naming pattern as before. So this looks correct. So our preludes are now coming in as import $Gleam, and then we're using $Gleam. And this one is importing Gleam, and that looks correct. It is importing Gleam. Yep, prelude usage. Hey, there we go. So this one is using both the prelude as well as importing this external module and then also prefixing the outputted type with that external module. So this looks absolutely 100% correct. And now we should be able to actually start checking in some of these. So let's take a look. We have import other, and then a function that returns other.to. This is the constructor, remember, and the actual name of the type is 1. So 2 is a 1. Confusing, but that's what we have. And this looks correct. So let's accept this. That looks absolutely correct. This is changing the prelude to use this name instead, and then change the name over here. So that looks absolutely correct. This one, importing other with a unqualified 2. So it's the exact same thing, but this time it's unqualified. And this also looks correct because it's, even though this is unqualified, doesn't mean our type has to be unqualified. So that all looks correct. And that looks correct too. So this is a constructor that actually takes an argument, but doesn't affect the types. So let's check that. And let's see, importing the prelude, importing this external thing, and saying this is a function that returns a list of custom. This is a function that returns a list of custom. Perfect. Let's check that in. So change the name, change the name, change the name. Looks great. This one does not look great. Oh wait, no, I take it back. Looks great. I probably would have preferred for the class to be exported before us using it. Also, I don't think this is correct. And what I mean by that is the name of this module is probably module. And we don't actually have a prefix called module inside here. So looks like when we're defining a type inside the current module, like here, right? Pub type mine, and then labels is a mine and no labels is a mine. We should not be prefixing. So it looks like our type printer needs to know when we're inside the current module. And when we're inside the current module, well, we can't just do this. We probably just have to have it unprefixed. So let's skip that. This is correct. Just changing the name from prelude to Gleam. Same thing here. This is correctly importing other, this time with an alias, but again, 2 is a 1, as is the alias. It's put to 3, so we're still outputting 1. That's still correct. This is just importing Gleam, which is correct. We're not using it in this file, but I don't think TypeScript's going to care that much if we import something but then don't use it. So we'll accept that. And changing the name. Correct. And here we go. Another instance where we're actually defining. So if I scroll up here, we're defining a type called true, which has constructors called true, false, and nil. And then we're asserting that the constructors match the inputs. And so this is just not, we can't prefix this because we want to use this type called true here, here, and here. So let's skip this one. And this one is correct. We're just aliasing. All right, we're through. So how are we going to teach the type printer about the current module? Well, thankfully, we actually already have references for this. So if I were to pull up Erlang, if you remember from episode 1, Erlang is where we grabbed our original type printer from. And if we take a look at that, you'll see that in Erlang, it already has the idea of the current module ready to go. So I think what we're going to do is just kind of take these ideas for ourselves. So for our type printer, we need type printer now to have a life cycle associated with it. And we're going to grab this, paste it in, and we're going to change the signature of the implementation so that it's got this kind of life cycle attached to it. And we need to change the signature of the new function because we need the current module to be passed into us. And then just like in Erlang, we actually need to save that for ourselves. So we should be good there. And then this needs to be scoped to the same lifecycle as the TypeScript generator. And then this needs to actually be past the current module, which should be a pointer to module.name. And there we go. So now our only warning is that we're not yet using this. Perfect. And so we need to go back to our app printer, our print type app. And what we need to do is conditionally set this name so that when the module this is coming from matches the current module, it's unprefixed. And when it isn't, we do actually prefix. So I think what I'll do is say let name is equal to match does module equal self dot current module. So we're going to create this match function, and we're going to say on true, it does match. Then all we need to do is output this last bit. And on false, we actually need to do all of this work. And we'll just return this at the end of the match statement. Oh, and we need a semicolon. Perfect. Okay. So now what we did is we said the name is going to be if the module is equal to the current module, then just the unprefixed form. Otherwise, we're going to, generate this module name just like we do below, and we're then just going to add it as a prefix. So let us run cargo test again. And hopefully those last two tests that we had failing should be good to go. And moment of truth. We're just importing Gleam. Mine is now unprefixed because mine now refers to this mine. Oh, that's perfect. That's really, really perfect. Amazing. Amazing. Oh, so happy. Okay, that has worked. And if we scroll up to the other failing test we had, so X is a true, X is true, X is true. So these are all unprefixed now. But I'm seeing one last issue. Okay, let's at least check in this one and say, yep, that's good. This one is still wrong though. And I'm realizing it's still wrong because you'll notice true has 3 constructors. So it has a true constructor, a false constructor, and a nil constructor. So a true could be a true, false, or nil. And it's a little bit unfortunate that the constructor matches the type name here because that could cause us issues in TypeScript. So we'll have to figure out how to reconcile that. But what this is really saying is true is a union of these 3 constructors. And yet down in the generated TypeScript, at nowhere in this file, we do define the 3 constructors, but we don't actually define that union saying like, type true is equal to the union of true, false, and nil. So I think we have to update our type printer one more time to add that into here. So let's skip, close that down. And how are we going to do that? So the name here was true. Let's see. So we're getting in our type app. Is this the constructor? I think this is the usage of an app type, but not the actual construction of an app type. Possibly. Let's see. We have a var. We have an app function tuple. But how do we know if we're actually in the construction of an app? Because when we're in the construction of an app, what we need to do is that union. This just refers to the usage of it. Let's take a look at that test again. So inside here, we're saying pub type true, these usage. So this is when we are going through our statements. I see. So we're going through our statements, and this is a, let's scroll through our statements here. This is not a type alias. This is a custom type. Yes, this is a custom type that we're exporting here. So let's go to our custom type definition. And so I see we're constructing the constructors and returning that, but we're not actually, what we need to do is we need to push onto this. We need to push onto this, basically the actual type constructor here. So the actual, what we need to do is say, you know, if the length of the constructors is greater than 1, then we need to say type x is equal to, you know, A or B or C. So that's ultimately like this pseudocode that we need to get to. But sometimes a constructor can actually match the type name. So I'm thinking we have to do something to prefix this type name or postfix it with maybe like x type is equal to x, b, or c. And then we'll have to just make sure that whenever we're importing a type, we prefix it or postfix it, sorry, with this type. Append it. Maybe append is the right word there. Let's see. Yeah, that sounds right. So let's try and do this. So first off, let's say the definitions is equal to this, and we'll make this mutatable. And at the end of this, we want to return those definitions. And then we want to say this exact if statement. So if definitions dot length is greater than 1, then we want to push onto the definitions something else. So probably a docvec, make our life easy. And so what do we want to do here? We want to say type type space format and so this needs to be the actual name of the type. So let's see. Public constructors. We probably need to pull out the name. Yep, it has a name on it. So let's just grab that. Okay. In fact, you know, let's not even do this when we're greater than 1. Let's just always do this. That way, if the construct, you know, the logic just gets a little bit simpler for ourselves. We're always going to generate the X type. And even if it's just referring to one constructor, at least the logic will be the same each time. So we need to actually put that name here. So this will be name is a string. And so we're going to just put name, prefix or postfix, append it with type. And then we're going to say space equals. And then what we need to do is basically for each constructor, we need to basically intermix them with that type operator. So let's see. Need a comma there. Type annotation needed. It doesn't know what this is. This should be a document. So this should be a vector of document. And we don't care. Okay, perfect. Maybe it's a vector of output. And so this needs to be surrounded with an OK. And cannot return value, temporary value, returns a value. I see. So I've seen this before, and when that happens, I have to just wrap these with document string, or else it does not like my usage of docvec. And what is complaining about now? Oh, and I need to call toString on these. And does it like me now? So close. Let's just try putting this one also in a string. Okay, perfect. So we need to do that interweaving of the names. So we've done this in a few other places. Normally looks something like this, where we use concat intersperse. Yep. So we're going to concat interspersing. And then we need to give it a iterable. And how we're going to then break these up. So I think, let me just search to see if the pipe is currently being used anywhere. I don't think so, unfortunately. So I think we'll just have to copy that break that was being used. Yep. So we'll just copy that break. Grab that, scroll up. That will be the second argument, and then replace that with pipe symbol, and we'll do that. Oh, I actually think this is being used in Erlang someplace. Okay, and then the first argument needs to be that iterable. So we're going to say constructors dot iter. So we're going to go through each one of these, and we're going to map them. So this will be x, and we do want to do x dot, and what is in this type record constructor? We need some sort of record constructor. We need its name. Yep. Does it like us? It may like us. I'm not seeing any errors. Okay. Let's run the test, see what happens. And if this looks horrible, we'll go to Erlang and see how it's doing it. Okay, that looks kind of correct. Oh, it's missing a semicolon at the end. So we will want to put a semicolon at the very end of these, but okay, that's looking not horrible. It's definitely not looking horrible. Okay, so the formatting is a little bit off, but definitely this true type is happening, and we're missing a export. Whoops. So we need an export here, and then we also need a document string of semicolon. And so I think I just need to make them like that. Let's see. If we go again, and now we'll have to just change how we import these. And then hopefully, hopefully, we should be all set. Okay, that's looking beautiful. We could also instead use some sort of, instead of the word type, we may just want to do like a $sign or something like that, some other identifier that would be safe to use, that we know that we're not going to get any accidental conflicts with Gleam. So maybe we'll change this to $sign to kind of keep up with the $sign motif here. And now these look beautiful. Yep, this is absolutely correct. So true, false, nil in the true type. Excellent. So we will append a $sign here to replace the type name. And then when we import these, so that's in our type printer. If we go back to the type printer and we go to our here, so we're printing out the module name, but we also need to add a $sign to this. So we're going to format. At this point, we should probably extract out this because the logic is now getting shared, and then we want to format this to this $sign. Whoops, $sign. And then here we can put name. And here we can put name. So we're just kind of building up this name. First, we append a $sign, make sure it's a type safe name, to camel case, and then we either prefix it or just turn it into a document string. And then finally, we just kind of go down the rest of the path. And this could just be probably name. Just realizing an empty doc vec like that could probably just be the name. Okay. Okay. Let's run our tests. And so what we've done now, just a recap episode, we've gone through, we've added all the import statements, we've made sure to prefix the actual names of the types to refer to that imported module unless it's coming from the current module. And now we're making sure that we have these unions in place when there's multiple constructors. Okay. Okay, so this is getting a little funny looking, but this is what we now expect because the module name is prefixed while the type name is appended with a $sign. So that is correct. Now, I don't know if that's what we'll end up doing full time. Probably during PR time, I'll ask more of the Gleam maintainers if they like this syntax, but it's easy enough to change. We just have to change it in both places, both where we generate and import. But for now, I kind of like the surrounding of the variable with these $signs. I think that looks kind of neat. And we're guaranteed not to clash with anything else going on here. And these are looking correct. We're now saying export type mine $sign is equal to that thing. Cool. And we're referring to true. referring to true, we're putting a true, and the true now is the actual union of these three constructors. So this is a much more true statement than before. And I think we're ready to check all this in. All right, let's do it. So we're going to run our Insta review. We're going to say, yes, we're going to accept that. We're going to accept that. We're going to accept that. Going to accept that. Going to accept all of these and that one. And beautifully, we're going to finally accept this one, and we should be done. All right. I think that kind of wraps up this ticket. I'm going to do some work to clean up my commits, as well as some of the code, and just make sure everything's in a good place. But I will be opening up a PR later today for this. Thank you all for watching. I know this has been an extremely long series of videos for me to just add this kind of simple TypeScript type definitions, but I hope this was at least interesting. An introduction to Gleam, maybe an introduction to Rust if you haven't done that before. I'll be posting many other videos like this one, maybe with better editing, probably not, but thank you all for watching, and I'll see you all next time. Cheers, y'all.